Now your diaphragm does what? You're going to expire. Your diaphragm contracts. Now it's getting what? Your thoracic volume is getting smaller again. Right? Okay. Now guess what happens? Those numbers of molecules that you've had, I've got 1, 2, 3, 4, 5, right? And I've got how many in here? Look. Now the pressure does what? Now increases above what? Atmospheric pressure. Right? Did I lose anybody in here? Because you need to say that in your exam. Then you see me after class. Sounds good? When do you have a break? Do you have class after this class? See me after class. Yes?
I thought on inspiration the pressure decreases.
Right. The pressure decreases, so you'll have what?
Room for more air.
Gradient. So the air can move down. Now the air is moving down. Your pressure has to start building up to go to what? To equilibrium.
The increase that's at the end of inspiration.
Yes, because not at the end, slightly when the air gets in, slightly it starts, because now we don't have the same number of what? Molecules. Do we all agree with that? Did I lose anybody? If I lose you, then see me please after class. You need to understand this concept. Okay? Now the pressure is what? When I contract it more, it's gonna do what? When I pull it up, the diaphragm, it's gonna be increased more, right? Guess what? Your thoracic cage decreases in volume. Now you have atmospheric pressure is what? Below
Alveolar.
alveolar, because your alveolar is above 0 now, right?
Right.
Yes.
You're using a Sharpie on the board. It's not going to erase everything.
Oh no.
Oh, darn it.
There's stuff.
All right, take a deep breath.
You know what? Rubbing alcohol will probably take it off.
Yep, rubbing it
Or
off. Actually, she can write over it with the eraser one and it should come off.
You think?
Yeah,
Let's try it.
So right on top of all those ones were dry erase.
Oh,
You're
yay.
so smart. I know.
Wow, we all get an A then, don't we?
Yay. I don't know why it works, but it works.
Yeah, that's crazy.
Okay, we'll fix that later. But do you understand this concept? Do you understand this concept?
Yes.
Okay, now your alveolar pressure is what? Okay, use this one right here. Alveolar pressure is above
Atmospheric.
atmospheric pressure, which is 0, right? Okay, now you what? Air travels up
and out.
You exhale. Any question about that? Only 2 people told me that pleural pressure is negative on inspiration and positive on expiration. That is absolutely wrong. Pleural pressure is always negative on resting inspiration and expiration. Yes?
Wouldn't it be easier if you put alveolar pressure as a positive and then put atmospheric pressure up top as a 0? Because all you're doing is flipping. Because
Would it be easier if I do what?
well, the pressure's higher. Alveolar pressure is going to be higher than atmospheric
This
pressure.
is 0, this is atmosphere.
Yeah, it's fine. It's just saying in the gradient because you're using a negative there and you're not using it
So this is positive now.
right because it's
How about that?
it's all air's
Better?
always going to flow from positive to
To
negative.
negative,
So if it's
exactly, from high to low.
yeah, like pouring a glass of water.
Yeah.
Put a glass of water, fill to the brim, it's now equilibrium, and pour more on it, flows out.
Whatever that makes you understand it, seriously. But do you understand?
Yeah.
This is what I'm expecting in the exam.
You want the
I
picture?
will, whatever that makes you think, because it is a process. Your diaphragm contracts first, and that's what makes your thoracic cage what?
Open up.
Open up. So it doesn't open up just by itself. You have a pressure gradient, and this is, now you're creating a pressure gradient because what happens to the alveolar pressure and the atmospheric pressure. This is what I'm looking for. Process 1, 2, 3, 4, 5. Okay? Nothing before the other one. I was very easy correcting that quiz because I want you, the reason I give you those quizzes not to go home and copy. No, I want to know what you understand and what you don't understand. Okay?
I don't feel too generous on mine.
I'm not. I don't understand how the fuck you gotta get up on that.
What's the matter?
This is directly from the book. So how do I have a body that's because of that. Didn't I
Okay, we're
just
all
say
done with the quiz.
that the right
Any
capacity
question?
increases? What did she got right there? What is that? Your diaphragm controls first and then thoracic. Okay, what does that mean?
Yes, ma'am.
It's the same thing. You're saying the same exact thing.
Yes.
I don't
because
understand
wrote
what that
it here
means.
because I did not
Yeah,
see
it's
it.
exactly the same
I was
because
reading
just
up here,
because you
and then
said
I'm
the
like,
volume
okay, this is
increases,
the
which
process,
causes
this
the
is how
downward
it is.
contraction. I think what she's saying is you need to have it flipped, that the diaphragm, when you take a, the diaphragm goes down. I see it as the same thing. You know what I mean?
Right.
That's all. I would ask.
I am fine. Because that's both.
Okay.
Oh,
Any question with the take-home exam?
Number 3. Oh, I already took a personality. I mean, that's who I went to. Okay.
Number
Number 3.
Number 3A, I know that's just a conversion, doesn't have anything to do with decreasing flow or pressure, but for some reason, many of us were, including myself, were very confused about that. Simply converting 30 liters per minute and trying to find out what is that liters per second. I divided and I got 0.5
30 liter per what?
per minute.
Per minute,
And
right?
all you asked us to do on that one is convert.
Just convert. 30 liter divided by 1 minute, right? That's what it means. Correct?
Yes.
I'm converting. Whatever I multiply to the top, I'm supposed to multiply to what? To the bottom, right? 1 minute, but 1 minute is same as saying what?
60 seconds.
Okay, so that's correct.
So what's going to be?
0.5.
0.5.
That's all. That's
Okay.
the only thing I asked for. And I went step by step for you, so you know. I didn't expect. I asked you for those steps, so you know your mind is only focusing on one thing at a time.
I look at that you just think about what you have to get rid of, right? In a
Whatever that helps
yeah.
you.
I mean,
Other questions?
wasn't there something on the back?
Yes.
Number 2 on the back.
You said 0.5?
I have a question on the multiple choice.
Go ahead.
On number 1, it says when the person's lungs are highly compliant, it means that
2.7?
Stop right there. If I tell you your lungs are highly compliant, they're going to have the ability to do what?
just scratch.
Okay, keep going.
But there's another option, B, compliance is expressed in high numbers. And I looked at like a chart on page 92, and I guess I was just a little confused exactly how that related.
What's normal compliance?
Per man, 500 milliliters.
0.1 liter per centimeter of water pressure. That's normal compliance. Okay?
So, is low lung compliance?
Remember we talked about this, and we said, she's talking about this graph right here. Do you remember when we talked about this and we said, at the top, you don't have a lot of compliance. Why? Because as your alveoli is being stretched, you come to a point you cannot stretch it as easy when it's what? Already stretched out, right? The best is right here where your alveoli has the ability to stretch out, right? Now, this has nothing to do with the numbers. This is just explaining to you if you have an alveoli and your alveoli is going from here to here to here to here. Now this is probably the maximum. Your compliance is not going to be great at this point right here because it's at its maximum filling capacity. Understood? So if your compliance is, if you have a higher compliance, you're going to have a what? Higher number.
A higher number.
Right?
Higher number?
Yes.
Because your lung is
That picture,
So
it
which
does
one?
not talk
So
about
which one is
numbers.
it?
It talks
I don't know
about
that.
the filling capacity of the alveoli.
So, the answer to that would be the lung tissue is there.
I think it's B and C because the lungs are easily inflated and
Right.
compliance is a high number.
So, you're right.
You're right.
Yeah.
So if I tell you somebody has a compliance of 0.01 liter per centimeter water pressure, and I tell you somebody has a compliance of what? 2 or 0.2 liter, which one is higher compliant? Just the higher number, right?
Okay.
Do you? This is
Yeah, I
all
followed the
to it.
graph
That's
instead
it.
of the-
That's all to it.
So is it C or D?
So then it's E, right? Easy inflating, lungs are easy to inflate, and then the compliance is at a high number, correct? It's gonna be Mary, because it,
I don't know.
well, highly compliant means your lungs are gonna be easy to inflate. It's
Exactly.
highly compliant. So then it's
Exactly.
also a high number, so you're covered too.
That's right. Next.
I will. I'll ask number 2.
Come on, people. Next.
All right, a couple of us had a question with number 2. That's the question with premature infants often have a low concentrations of
Stop right there. Surfactant does what?
surface tension.
And it makes your lung what? Highly compliant or less compliant?
Less.
It's not easier to inflate.
It's recoil, right?
Yes, so it's not, because it's just the opposite. So it's not as easy to inflate, okay? If you have somebody, forget about the infant. If you have somebody that has atelectasis, collapsed alveoli, it's gonna do what?
Increase the less.
It's gonna take more pressure to inflate it, right? So it's not your lung. It's not gonna be as compliant. It's not gonna be as easy to stretch it out. So when that happens clinically, your patient will having hard time breathing. Your patient will be using accessory muscles to breathe. Your patient is having increased work of breathing.
Right. I guess what's confusing to many of us is there's 2 answers. So we know one of them obviously is increased work of breathing.
Okay.
And then it does say about could there be a decrease in elastan?
All right.
Or an increase?
Then
It's
you
an
tell
increase.
me. You tell me what's elasticity.
It's recoil.
So if you don't have enough surfactant, what it's gonna do? It's gonna tend to do what more?
You're going to recoil
Recoil.
more.
So it's gonna be increase or decrease in elastance. Increase. Everybody get that?
So 2 and 4.
Your next exam will not have any multiple choice,
Say what?
but learn your definitions.
Do you mean the exam on Thursday?
Well, I'll go over it. Mission accomplished. Yes. We'll talk about the exam later. Take home exam. Any other question? Yes.
Okay, on number 4, you gave us E, radius of tube. And it
Number
is-
4, multiple choice.
Yeah, it is just radius of tube. It's not radius of tube and something else. It's just radius of tube. That was one we were missing, E.
Yes. The E, it's the radius of the tube or the vessel or whatever. So in order to answer this question correctly, remember Poisson law. We
Right.
said the most one that influence flow is what? Radius. Because it's to the fourth. If it's cut in half, your flow has to decrease 16 times, which is the same as saying what? 1/16, right?
So it's
So
just E.
another question has 2 answers, and I will accept 2 answers in this one, and that would be question number 8. Any other question? How are you guys doing with the math? Because you will have math in your exam.
I don't get it.
You don't get what? The math? None of it.
See me after class.
You were not here. Okay.
See me after class.
Anybody else has questions other than Laura, right?
Number 1?
Number, yes.
Do you know if there's anywhere that we can go to do practice besides the book that we have? Like, is there a site or anything that would help us out?
No, but
I do. I know where you can get practice.
where?
Wednesday after class, I'm gonna sit down with Erica.
Erica.
Get together. That will help you a lot. I'm serious. Get together because many brains can think better than one brain, and the more you sit together and talk about it, the better you understand it. Yes.
I just had a question. My question is, it's about to take an exam, so I don't know if you're still doing it yet. Is the inner pleural pressure and the inner alveolar pressure, will they generally always match each other?
No.
Like if it's negative on inspiration,
They will,
inner
on
pleural?
inspiration, both are negative.
Negative.
However, on expiration, your pleural pressure is always what? Negative even on expiration.
Right.
But your alveolar pressure is what?
Positive.
Okay? Any other questions?
So 7.
So plural
Yes.
I'm talking about 7.
Please, quiet, please.
So would you,
6A, I just want to make sure I understand how to do that maximum tidal volume. So you're taking 62 kilograms.
Okay, what is the number that you have in here?
It wants the maximum tidal volume in pounds, and that's 62, the patient weighs 62 kilograms.
62 kilograms, right? What am I looking for? Maximum tidal volume, right?
Right.
In order for me to know the tidal volume, I can know it if I have kilogram or if I have pounds. What is this on? Kilogram. What's the maximum we set? 5 to what? 7 ml per kilogram, right?
Right.
5 is what? Minimum. 7 is what?
Max.
So if I'm asking you for the maximum, what do you do?
7.
You multiply it by 7.
you said 4.
So if I say in pounds, what are you going to do? You're going to 62 kilogram, you're going to convert it to what?
2.2.
You times it by 2.2, which is equal to what?
136.4
What?
pounds.
Pound. Now, what is it per pound? 3 to 4.
In math.
So what do I do in here if I want it the maximum?
By 4.
I times it by 4. If I tell you the minimum, you times it by
3.
what? By 3.
You want us to carry the decimal place out? Can we just use 136 pounds for the equation?
I would like to get at least 1 decimal.
Okay.
Yes.
So if I take that 136.4, right, and if I want the high end, I'll times that by 4, and whatever that comes out to, that is my tidal volume.
If you're setting somebody on the ventilator and you want to know, I know the weight of the patient, I don't know, the doctor did not give me any order for the tidal volume, this is how I figure out my tidal volume.
And without that times 4, is that dead space?
That would include your dead space, but that's
So,
not
okay,
your
so
dead
it's
space
7,
only.
we're going.
Because it includes your dead space and your alveolar ventilation.
So my dead space is the
What's your dead-
136.4, but
hold
it's
on.
actually milliliters.
Hold on right there. What's 136.4 times 4?
That is my DT, is my tidal volume.
Okay.
What is
Right.
it?
5.5.
Well, 3 is for sure
Five.
with the intrapleural pressure, but the what? With the
And I'm doing what?
intrapleural pressure.
Milliliters, right?
Things that when you inhale.
Everybody, please listen. What's the dead space in here?
136.
What is it? It's right in here, 136.4. So
Yes,
minus
you
136.4 would give me what? 409.2. That's what?
Alveolar.
My alveolar ventilation. Got it?
Yeah.
Got it.
Question. All right.
I thought that was in
Wait, is that labeled
dead space.
What's dead space? Dead space is equivalent to what?
1 milliliter per pound.
The weight in pounds, right?
Oh, right, okay.
Got it? Any other question?
Especially when it's not being shown.
After the 5.5, we know.
Absolutely. Because it's what? It's volume.
Yeah, I was thinking
Right.
like
Right. It's the weight, but when you want to do the dead space, you're looking for the volume, so it's going to be in milliliters. Okay?
Mhm.
Any other questions?
I have to be comfortable with number 3.
Yes, times
No,
the
no, no.
frequency,
I'm sorry.
respiratory rate, whatever you
Number
want
3,
to call it.
Kuzma? Oh, yeah. Kuzma?
All right, so that
Oh, yeah.
409.2 is called my alveolar,
Ventilation.
Okay.
and that would be, what's the symbol for that? I know it, I'm just seeing what you know.
Put your,
Okay, you saying.
okay, I'm gonna go over this, but I need, if you're done questions about your exam, pass your exam along.
You want the quiz too, right?
And the quiz. Both quizzes, actually.
Oh, both quizzes.
And see me after class if you have a question.
You want them in separate piles? Would that help you?
No,
I'm
just
sorry,
put them,
Nancy.
you know what, yes, go ahead and
Separate piles.
We use it.
Both.
Do you need the quiz back to study off of, or?
Yes.
Quiz 2 and 3. Oh.
Okay, I'm missing something. You guys, I'm missing this. Okay.
I got a question on my
After class.
on my quiz too. Yeah, after
Oh,
class.
I'm sorry, my
On
class.
this because I gave you the same
After
meaning.
class.
And,
We
yeah.
meet after class.
Yes, I will see you after class.
Okay.
All right. So what are we doing here?
3 piles.
Oh, okay.
Do with me in your take-home exam. Yes, sir.
Are we need to give this back to us before we leave these for study guides, and then we give it back to you like we did?
But you want to see
For
her.
the take-home?
And then here's
Yeah,
this.
please.
This is what
Take-home, I didn't give it back to you.
quiz
That's
number
it.
2.
Take-home exam, I did not give it to you. If you want,
I'm like, what?
I will upload it on Blackboard.
Yeah, that's my head.
Where's quiz 3? Where's quiz 3?
Huh?
Did you guys give me quiz 3?
Yeah.
Where? I got one here. I got take home there. Oh, did I miss it? Oh, there you go. That's quiz 3.
And then there's, oh, what's this? Like, see, when they don't, it's not typed, it's throwing me. I'm like, what is that?
Okay.
Yeah, I copied this.
Okay, can you do me a favor and put it in separate
Oh,
files?
did I not copy that?
This is what?
2, 3, and the
Oh,
exam.
did you
It's all
get that sheet? I
separated.
made a copy of these ones. Okay. Are we good? As good as we're gonna be?
Don't worry, I'll figure it out. Just give it back, that's fine, I'll figure it out. Nobody else has ever done it, so you're good.
I'm sorry.
You're good, that's fine. Okay, your exam next week.
This week.
This week, that's what I meant to say.
Work with it.
This week. Let me pull it up. Nothing is, so I have everybody's exam in here. If I tell you, give me the abbreviation of static compliance. It's compliance and it's static. Right? If I tell you dynamic, see dyne. IE ratio. I to E, right? What else did we learn? Minute ventilation with the E. Alveolar minute ventilation. What about just
Elastic.
alveolar ventilation? VA.
I have a question.
Yes.
For dynamic compliance in our Egan's book, like on the front cover, it just has a C and a D, and I did put the DYM because that's what I had in my notes here, but what is,
It
what
just,
should D have been
the
correct?
only reason we do that for you to differentiate between dynamic and static. If you're saying, remember later on when we start talking about mechanical ventilation and you start talking about this course and they tell you what's the compliance, what are we talking about? Static compliance or we're talking about dynamic compliance?
Okay.
You know, so just put C down, you know, so for you to get used to this. Okay?
I know,
That's
right?
okay. What else?
Wasn't elastic? Elastis was one, just an E.
What else? Compliance? That's it. You've got two kinds.
We don't need to worry about
Is that CDYN, is that correct?
Mm-hmm.
Tidal volume.
What's tidal volume?
VT.
VT. Minute ventilation is on the board.
Anatomical, physiological.
Dead space. How would we do dead space?
DD,
It's
right?
BD.
VD. And what VD, that's dead space. Okay, fine, but you're not specifying. Is it alveolar dead space or anatomical dead space?
Anatomical.
If it's
VDAN.
anatomical, it's going to be what?
VDAN.
A.
VDANA.
If it's alveolar, it's going to be what? Got it? I think that's about it, right? Respiratory rate? Let me write it right here. You need to know those for your exam. For your exam, you need to know the diaphragm, how it, when it contracts, what happens to your pressure, what goes up, what goes down, and just on same process as I told you about. It's a process. 1, 2, 3, 4 happen. Nothing happens before another thing. Okay? You need to know your math, just the way it was given to you with your take-home exam. What else? I don't have it with me. No multiple choice. You need to know your formulas. All the formulas that we talked about. Vasoila, compliance, elasticity, minute ventilation,
I don't know.
formula. What is it?
All of them have
Yes.
different quiz.
And the take-home exam. You need to know the abnormal and normal pattern of breathing. And those would be matching. I'm not going to tell you write it out for me. But I want to know if something is presented to you, you know what kind of breathing this is. Apnea is what? No breathing,
Yeah.
right? What's eupnea, we said?
Normal.
Small breathing. That fast and deep breathing. It's regular, right? And we said it's associated with what? Diabetic ketoacidosis. They've got what?
I don't remember.
It's associated with ketoacidosis,
Acidosis.
right? Now, what kind of acidosis they have? Is it metabolic? or
metabolic.
respiratory?
Metabolic.
Metabolic acidosis. That's it. What else do you need to know?
Do we need to know like things like for like transpulmonary pressure, this pressure?
It's a fair game if I tell you to write the
There
formula.
we go.
But we're not gonna have to do any of those?
No. Calculate? No.
So we just, but
Absolutely
abbreviations
not.
you want us to know,
Yes.
but other than that,
Just
We
the
don't need
formula
those
if you know the
calculations.
formula what it is. Another thing, you're supposed to know if your pleural pressure is positive or negative on inspiration and expiration, if your alveolar pressure. And we went through this, right?
It's negative upon both pleural pressure.
Yes.
but what is the
Any other question? I guess the hardest part in this test that students find is the math problem. If you get the math problem and know how to do it, it's a fair game if I tell you, and I think I gave you this in your take-home exam. So minute ventilation is what? Respiratory rate times tidal volume. Right? Okay. Now if I tell you, I give you this, and I give you this, and I tell you what's the respiratory rate. Can you get it?
So you divide.
Got it? Divided by respiratory rate, and then you divide it by respiratory rate, right? Let's just cancel. I don't know. I do math different than
Yeah,
it's
it's like, wait a minute.
Huh? That title bar. Right. If I want it the.
Oh, I'm like.
That's right. I think I want the respiratory rate. Got it?
Yes.
But did I get you confused?
Well, you did, now I get it.
What is G static?
Anything else?
Static compliance.
Static.
Anything else? That test shouldn't take you more than half an hour to 40 minutes to finish incomplete. It's mostly memorization of the formulas. If you know them, you should be good. It's mostly abbreviation, math problems. And please, if you had a question in the exam, come and ask me. Because only one small thing can make you understand what that question is actually about. No multiple choice.
So it won't be a scan count at all.
And then, do you want our workbooks on Thursday? 'Cause I know
Next week, because your exam was supposed to be next week. And let me say that from now, since we moved this exam 1 week, probably your next exam will be moved another week. Okay? So you guys know. Any other question? Because it's supposed to be next week.
So we're having this.
It was supposed to be next week, but everybody wanted to have this.
I thought we were different.
No, we moved it
Question?
No, I think yeah. Yeah. I'm not saying the next one.
Okay.
We'll just keep it next week. Yes.
Okay, just for clarity.
Sure.
Your freshmen are gonna be negative on inflation and.
Yes, however, on inflation, it becomes what? Less negative. It'll be negative, but
Right, so
less
that's
negative.
negative, but it won't be positive.
Never positive unless it's inflation.
Okay. Now, alveolar pressure.
Well, I have that.
I have that.
Positive because you want to create a professional rate for the air to move out from the lungs.
Right, but it's gonna be positive on exploration, right?
Yes.
Because the alveolar pressure is gonna increase because it's greater than atmospheric pressure. Okay.
Any other questions? Okay, listen to me. 5 minutes. Take a break, 5 minutes. I need everybody back in here in 5 minutes. Thank you. You're welcome. We're gonna start with Unit 3. I thought 2. We're gonna keep going.
Okay.
No, we're done
Yeah, I
Unit 2.
got one.
That's it. We're done.
Oh,
We're starting Unit 3.
do you have
Yeah.
it?
Yeah, I got
Is it just
it.
one page?
I printed it out yesterday, yeah.
That's it?
Mm-hmm.
Module 3 is one page.
No, we're starting
it.
new material. We're done. What are we gonna do? And it'll be an introduction. And you always know when I start, I introduce things to you so we can build up on it, right? Okay, so let's start. And stuff that are not new to, I just talked to Kathy Miller and she said that she introduced Dalton's law to you, right? So this is basically what we will be talking about. Stuff that are not completely new to you, trust me.
Okay.
Yeah.
Yeah.
This is Dalton's law right here, module 3.
What is it?
The module 3 is Dalton's law.
Dalton's law, alveolar air equation, old and new things. You've probably seen most of those things with Miss Lee. So, okay, barometric pressure that we breathe in. What's the pressure for?
760 millimeters of mercury.
Right? But that pressure, barometric pressure, is composed of what?
Nitrogen and oxygen.
Gases, of different gases, right? It's composed of what? Nitrogen?
Nitrogen and
Oxygen,
Argon and carbon
argon, carbon
dioxide.
dioxide, and all these things are, let's just say CO2, because we care about these two, right? And this one, okay? Mostly it's composed of what? Nitrogen. What's the percentage of nitrogen?
79%.
Actually, just a tad less.
You know what? Don't get overwhelmed with 1% plus 1% more. What's more important is it's composed of mostly nitrogen, right? 78% nitrogen. What's the amount fraction of oxygen or percentage of oxygen?
21.
21%. What about CO2? It's not one. Nope. Right? Now, if we're breathing room air, we're getting how much oxygen? 21% only of oxygen. Do we all agree with that? Yes. If I was at the hospital and I placed somebody on a nasal cannula, will I be giving that person 21% of oxygen?
No.
No. It's going to be higher. Higher. We all get that, right?
Yes.
Okay. A frequent term that you would see a lot in the hospital is fraction of inspired oxygen, which stands for FiO2. Have you heard this term?
Yes.
Good. So, if the concentration of oxygen in air is 21%, your FiO2 fraction of inspired oxygen is 21 divided by 100 equal to what? 0.21. You will see people using those two terms the same, okay? For your board, if they're asking for fractional of inspired oxygen, it's not going to be in percent. You gotta divide it and actually put the term 0.21. Okay? Okay. Good. So, if I draw this and I say this is my barometric pressure, it's gonna be composed of 21% oxygen. It's going to be probably right here, nitrogen, get like this, 78%. And this is 0.03%. This is CO2, this is nitrogen, and this is oxygen. Correct? When we talk about partial pressure, it's measured in what? Millimeter of mercury.
Right.
Okay, how do we convert 21%? How do we get the partial pressure of oxygen out of this whole 760?
0.21 times 7.6.
All you have to do is the fraction of inspired oxygen times 760, because this is all is what? 760. So it is 0.21 times 760, which is equal to what?
159.6
What's the unit?
millimeters of mercury.
So basically, out of the 760, for the whole gas, we've got 159.6 millimeter of mercury of oxygen, partial pressure of oxygen. Okay? Now, this partial pressure of oxygen, you would see it written like this, PaO2. You would see PaO2, and you would see PO2. This is in the air. This stands for alveolar, and this stands for what? Arterial. So if you see those, you know what I'm talking about. In the air, it's 159.6. Okay? Similar to this, if I tell you to find for me the partial pressure of nitrogen, what would you do? 0.78 times 760. And that will give you in millimeter per mercury how much the partial pressure is. Is everybody understands this so far?
Mm-hmm.
Good. Now, as we breathe in air, air goes down through the conducting airway and it gets into the alveoli, right? There is a partial pressure for alveoli that's slightly different than the partial pressure in the air. Why? As air gets in, your body temperature, what is it? 37 degrees Celsius, right? So it's warm. Not very hot, but it's warm, right? So now, as it's passing by, you've got vapor. You've got gas that changes, liquid that changes from liquid to vapor. And you've got what? Partial pressure of what now? Of vapor, of water, okay? So because we add the partial pressure of the water that's going into your lungs, it takes up a little bit from the oxygen, partial pressure of oxygen, to get the total of 760. Okay, so now instead of having this is all going to be 760. Now we have oxygen, we have water, we have this. That's not right to say because it's not, there you go. Like this, even less. H2O, we've got nitrogen, and we've got CO2, okay? So we added one more component to it. So the partial pressure in your alveoli, when we're talking about partial pressure in your alveoli, it's going to be what? Close to 100, the AO2, sorry. A 100 millimeter of mercury. Did I lose anybody right here?
Yeah, what was that?
What is that?
I don't understand.
That was
PaO2, so 800.
alveolar.
Oh, PaO2.
Yeah.
I'm sorry, the 100 millimeters of mercury is,
That's in your alveoli.
okay.
Okay? That's saying that you're breathing what? Atmospheric air, room
Okay.
air. Okay? Where 21% is coming in, not more than 21%. As it comes in, this is your partial pressure. When it hits your alveoli, it's 100.
Okay.
Okay? Got it? Okay. Now, what comes from here? What kind of blood comes over here? Is it oxygenated blood or deoxygenated blood? This is your alveoli.
Yeah.
Deoxygenated
Deoxygenated.
blood. It comes in here, and you've got, it has CO2 and O2, O2 and CO2, right?
Mm-hmm.
Okay? Now, you've got CO2 as well in here and O2, right?
Yes.
And right in here, you've got CO2 and O2, correct? Now, as the blood traveling, it's coming deoxygenated. Gas exchange is going to happen right in here. So what's going to happen to oxygen? O2 is going to come to the blood and gets the blood oxygenated, right? And CO2 is going to do what? Go to the alveoli so we can exhale it, right? And then it goes over where from here? Now it's oxygenated to the tissues to give oxygen to the tissues, right?
Right.
Look in your book and tell me, what is the partial pressure of oxygen in CO2 when it's deoxygenated?
Chocolate.
This is going to be chapter 4, about module 2.
Oh,
It's chapter 4.
That's chapter 2. Is it 3? No, chapter 3 is something else.
Oh, that's PFT. Chapter 3. Oh, okay, here goes chapter 4. Okay.
Page 190. This is really important, and I love this picture right here. Mark it so because it just gives you an understanding of what we're doing. Okay? So this blood, is it going to be venous blood or arterial blood?
Venous.
Venous blood. What's your oxygen in the venous blood? What's your oxygen in venous blood? 40.
Oh.
What about your CO2?
46.
46. What about in your alveoli?
100.
Your oxygen, we said what?
It's 100.
And your CO2 is what?
40.
40. How about when it gets in here oxygenated? Speak up. Let everybody hear.
Say reoxygenated?
When it gets oxygenated, right here.
CO2 is 100 and CO2 is 4.
Right here. We're at this point right here. Okay? Your oxygen is what? 100. It's fully saturated, right? And what's your CO2?
40.
40. What happens in here, gas exchange happens because you have low amount of oxygen that's coming in here. So because it's high in here, it's going to diffuse from what? From high concentration to low concentration. It's just going to diffuse in, right?
Mm-hmm.
CO2, 46 and 40, it's just going to move out. Okay? Have you talked about, with Ms. Miller, about the molecular weight? Which one is heavier, CO2 or oxygen? Nothing like that. Okay, let's not jump ahead then. Let's not jump ahead. Okay, so gas exchange happens, and guess what? Now your oxygen is what? Fully saturated. It goes to the tissue. Now you've got in here PaO2 and PaCO2. How do I remember those numbers? Your ABGs. Have you done ABGs?
Mm-hmm.
Yes, right? What's normal ABGs for CO2? Arterial. Which is average what?
40.
40. And your oxygen? 80 to 100. So it's 100. Okay, because it's now fully saturated. Okay? This is what? Your what? Your venous blood. Right? So your venous CO2 is 46 and your venous O2 is 40. Alveolar, this is 40 and this is 100, and this is represented as what? Big PaO2, CO2 and big PaO2. I want you to remember those numbers.
You're creating a gradient. Correct.
Yes, you did. That's why you've got venous blood coming, diffusion, and it's passive, and then CO2 moves out, oxygen comes in. Okay? I want you to remember those numbers.
And that's partial pressure alveolar gut.
Yes.
Yes, right?
We're talking about partial pressures in here. Yes.
So I'm just a little confused on the big A and the little a. The big A is arterial, correct? And the
Big
little
A is your alveolar. That's
Okay,
why
so I
it's
had it
written
wrong.
in what? In your in your alveolus right here.
Okay, so
Small a is in your what?
arterial.
Arterial.
I had them mixed up.
That's okay. Question so far? So, if you have a patient, let me introduce this term to you first. Bless you.
Bless you.
Thank you.
Who was that?
It's me.
Okay. So if I tell you what's PaO2 IE minus A gradient. What do I mean by that? What does P stands for?
Pressure.
Pressure. What's your big A? What's
Alveolar.
your small a?
Arterial.
So I'm asking the difference in pressure between your alveolar and your arterial. Okay? Now, let's say you have a patient, and we'll do it right here. This patient has an alveoli right here, and this is your capillary. That's not a nice one, but anyhow. And I tell you that patient is receiving partial pressure of oxygen is what? And that's big AO2. 100. Okay? I'm not giving extra oxygen or anything like that. And I tell you this PaO2 is equal to, what is it supposed to be after everything gets in? What is it supposed to be? 100.
Oh, 80 to 100.
100. No, remember the
Oh, the 100. Okay, sorry.
Fully
It's the 100,
saturated.
fully saturated.
Normal
Yep.
is 80 to 100. It's okay to have a little bit unsaturated, but fully saturated is 100.
Right.
Right? If I tell you you have a gradient of big A to minus A, which, did I erase it? I did. 40. What are you suspecting is happening? I don't want you to use the word shunting now. Did Ms. Miller start introducing shunting? Yes. Okay. Then guess what? Something is happening. Not all the oxygen that's in here is actually what?
It's not ventilating.
Whatever is ventilating, it's not going through. Okay? Does that make sense? We have a problem then. Right? Okay, good. Now, how do okay, fine. I got it. I can do an ABG. I can poke a person and I can find out what's their arterial O2, right? Easy, right? How would I find out what's my alveolar O2? Basically, it's whatever got in minus whatever got exchanged, you know? But how there is an equation for it, bottom line. It's math. You need to learn it. Yes, I will introduce it to you, and this is the last thing that we would be covering today. Okay? Just this equation. So, basically, and it's going to be what? Big PaO2, right? What's your barometric pressure? So, if I give you a problem and I give you the barometric pressure to be 740, then you use what? 740. If I don't give it to you, I expect to what? You know it, and you're going to put what? 760. Okay, so 760 minus. What did we say if I water pressure of water? pH2O. This number is going to be always 47 if I don't give it to you. If I tell you that number is changed to 43, what would you use? 43. All I'm doing, putting the norm. Okay? Now, it's times FiO2, which whatever oxygen that I'm giving to my patient. So if I don't tell you the FiO2, you suspect your patient is what? On room air, it's getting only 21%. But it's not 21%, it's written as what? 0.2. Got it? Everybody with me so far? Minus PaCO2 divided by 0.8. This is constant. This will never change. So if I don't give you PaCO2, you're going to tell me your PaCO2 is what? 40. 40. Divided by what? 0.8.
Okay, so PaCO2 is always going to be 47 unless you tell us different?
Water.
That's the pH.
H2O will be always 47 unless I tell you otherwise.
Always 47.
And PaCO2 is going to be the average?
It's going to be the average. Use 35 to 45, right? Your average of PaCO2 small a is what? 40. Okay? So let's start plugging in some numbers, and I tell you, you have a patient that you need to calculate the big PaO2. Okay? And I tell you the barometric pressure is, I don't even tell you anything about the barometric pressure. Use what? 70, right? Minus 47. What about if I tell you the water vapor pressure is 44? We're going to be using 44, right? Times your patient is on 40% FiO2. So I'm going to be using what? 0.4, right? Minus the CO2 is 35 now. Small a CO2 is 35. And then 0.8 is always what? Constant. Pull your calculators. $760 minus 44. What is it?
716.
Times 0.04 minus.
280.
What's 35 divided by 0.8?
43.7.
What's 716 times 0.4?
286.4.
Minus 43.7. What's your? What is it?
242.7.
Millimeter
Mercury.
of mercury. And that's your big PaO2. Usually it's there. Is it hard? Just plugging in numbers. It depends what I give you though, right? If I don't give it to you, you're supposed to know what's normal.
So we're going to have to memorize that formula.
Yes, you will have to memorize this formula.
That's to find alveolar.
That's to find your alveolar partial pressure. Because if everything remains constant, you know your alveolar pressure is going to be what? 100. If they're breathing 21% FiO2 or 0.21 FiO2, if the water vapor pressure is 47, if it's barometric pressure, and you know when you go on high altitude, your barometric pressure changes, right?
We only need this if things are off.
And I will tell you if things are off. I'll tell you if your patient is receiving oxygen. I will tell you if the water vapor changes pressure. I will tell you if barometric pressure changes. If everything remains the same, you will use the normal. More likely, your FiO2 will not be 21% because you're calculating it for a sick patient and your patient is probably on oxygen. Any question? That's enough for you. Was it that bad? No.
I understand.
Baby steps, step by step.
Just do that on the test.
Right.
Learn those normals that I told you about.
Okay.
Your PbO2, PbCO2, PaO2, small a, small PaCO2, big PaO2, and big PaCO2.
Okay.
All right.
Yes,
PbO2 is the same as the same.
barometric pressure.
It's the same as saying just PO2. If you
That's the air that you're alveoli, it's not in your blood yet. Yes, it's whatever it's gonna come into your lungs. Any question about the exam before you guys leave? Yeah. First thing in the morning, you will be taking your exam. After you guys are done, we will continue on with that.
Are you going to put the rest of them
For the lecture? Yes, but you know what? I don't want you to worry about it. Trust me, because next we will be talking about things that if you have, this is your alveoli and this is your capillary. What are the things that can affect the movement of oxygen into your alveoli, from your alveoli into your bloodstream? And things that you talked about, I guess, traditionally, because you did tell me that you talked about. So it's not going to be brand new stuff for you. It's a formula that you need to remember. However, before I even put the formula, we're going to be talking about it, understand it, because I will never tell you calculate. I want you to understand the physiology behind it, just like it's already on. Already on. I'll just ask you later. I know.
You got the abstract.
I know. But you know what I mean? I know, but you know what I mean? Less,
Yeah.
said that the thoracic fluid is development. I did write about the value. So paying attention to something. I know that
One by one.
On inspiration, the diaphragm moves down and expands. The thoracic cage, the pressure. What do you is decrease in the volume?
But doesn't your pressure decrease?
Yes, but your volume, that's the volume in your thoracic cage. Yeah. Your pressure in your alveoli and your thoracic cage. Not your thoracic cage. You know what?
Yeah, I get that, but I know that the volume is decreasing drastically.
But when you all the things that you really did not understand much better when you said thoracic pressure is when you're talking about thoracic pressure, we're talking about alveolar pressure. I see now what you mean.
You get what I'm saying? How I just worded it. The pressure is decreasing, the volume is increasing. And then, so now I want to know if this is what I wrote on our test, is this what I need to write?
Your diaphragm contractor. So your diaphragm contractor is and then what happens to your alveolar pressure?
Oh, the pressure gradient is now.
What makes the pressure gradient when you're thoracic, when you're
That's right.
that's what creates the gradient, makes the air move.
Oh shoot, this thing was